All right, let's talk about building for resilience in the cloud. Today, we are diving deep into one of the most critical concepts for making sure your applications stay online, Azure Availability Zones. You know, if you've ever had that nagging worry in the back of your mind about what happens if a whole data center just goes dark, well, this is how you build a safety net.
So let's set the stage a little bit. We all love to design and build for the happy path, right? For when everything's working perfectly. But the real mark of a rock-solid system, that's planning for when things inevitably go wrong.
And let's just ask the big, scary question right out of the gate. I mean, a data center is this fortress of technology. But at the end of the day, it's a physical building. It can lose power, the networking can get cut, the cooling can fail. So what happens to your application when its home suddenly goes offline?
Well, the fallout is immediate, and it's painful. If everything you've got is sitting in that one spot, your service just stops. To your users, you've vanished. And for the business, that's lost revenue, it's a hit to your reputation, and it's a huge headache for everyone involved. This is the exact problem we need to solve. And this is where the solution comes in. See, Microsoft has built this incredible safety net right into the fabric of Azure to protect you from exactly this kind of disaster scenario. So let's get acquainted with Azure Availability Zones. So what exactly is an availability zone? The key thing to get here is that it's not just one single data center. No, it's a unique, physical location that's made up of one or even several data centers, and it's built to be completely isolated from the other zones in the same region. They're close enough to talk to each other super fast, but they're far enough apart that a fire or a flood or a power outage in one isn't going to take out the others.
And that independence, that is the absolute secret sauce. Each and every availability zone has its own dedicated power source, its own cooling systems, and its own networking infrastructure. It's this total physical and logical separation that acts like a blast shield, containing any failure and making sure an outage in one zone doesn't cascade to the others.
Now, you might be thinking, okay, if these data centers are physically separate, that must add a ton of lag, right? But get this, Azure's networking that connects these zones is so high performance, we're talking about a round-trip latency of less than 2 milliseconds. That is ridiculously fast. It's fast enough to let you do things like synchronous data replication without your users ever noticing a performance hit.
Okay, so we know what these zones are, but how do our cloud services actually use them? It's not a one-size-fits-all kind of deal. For the most part, Azure services give you two main ways to use availability zones. We call them zonal and zone redundant.
And this right here is the big architectural decision you're going to have to make. Are you going to take control and place your resources in a very specific zone? Or are you going to let Azure handle the magic and automatically spread them across multiple zones for you? Let's break that down.
This chart really lays it all out. So with a zonal deployment, you're in the driver's seat. You basically pin a resource like a virtual machine to one specific zone, let's say zone 1. This is awesome for apps that need super low latency, or you want all the components to be physically close to each other. But, and this is a big but, if zone 1 goes down, it's on you to handle the failover. Now, with zone redundant, Microsoft handles the whole shebang. Your service or your data gets automatically copied across multiple zones. If one fails, Microsoft handles the failover for you. It is high availability right out of the box. Okay, let's visualize how the zone redundant model works. Think of it like a bank that stores copies of your most critical documents in 3 different, high-security vaults scattered across the city. When you use a zone redundant service, Azure is basically doing that for you automatically. So if one vault, or in our case, one zone, gets compromised, Azure just seamlessly redirects all the traffic to the other healthy zones. Your app doesn't even feel a blip. It just keeps on running.
Now let's contrast that with the zonal model. Here, you've chosen to put your document in just one single vault. So if that vault has a problem, your document is stuck. It's inaccessible until you personally go and get a copy that you hopefully made and stored somewhere else. In Azure terms, if the zone you picked goes down, that resource is offline. You are 100% responsible for having other instances ready to go in other zones to take over.
All right, so knowing the difference between the two is one thing, but how do we actually apply this stuff? Let's move from the theory to the practical and look at how to design a real-world, resilient architecture. And, hey, you don't have to just take my word for it. This quote comes straight from the horse's mouth. It's official guidance directly from Microsoft. The message here could not be clearer. If you are running a serious production workload and you're in a region that has availability zones, you should be using them. It's not just a nice to have, it's a fundamental best practice for reliability.
So how do you make a so-called zonal application resilient? Well, you basically take matters into your own hands. First, step 1, make sure your region even supports zones. Then, instead of deploying just one VM, you deploy at least 2, probably 3. Now here's the crucial part. You deliberately place each one in a different availability zone. And finally, you stick a load balancer in front of them all. Now, if one zone fails, the load balancer is smart enough to just stop sending traffic there and route it to the healthy instances in the other zones. Boom. You just built your own zone redundancy.
Okay, now for a really fascinating little detail that trips up a lot of smart people. That thing you see in the Azure portal called Zone 1, it might not be the same physical Zone 1 for your colleague. Let's peel back the curtain on this idea of physical versus logical zones.
This is a classic pro tip right here. You know those zone numbers you pick when you deploy something, 1, 2, or 3? Those are logical identifiers, and they are unique to your subscription. They don't actually correspond to a fixed physical building address that's the same for everyone. And this slide shows you exactly what I mean. Behind the scenes, Azure maps the real physical zones to these logical zone numbers on a per-subscription basis. So the actual data center that subscription A calls logical zone 2 might be what subscription B calls logical zone 3. So why does this matter? Well, if you're building a complex solution that spans across multiple subscriptions, you absolutely cannot assume that deploying to Zone 1 in both of them will put your resources in the same physical place.
And that really brings us to our final thought for today. We've gone through the what, the why, and the how of availability zones, all the way from the core choice of zonal versus zone redundant to the sneaky details of logical mapping. So the question I want to leave you with is this. Take a hard look at your own applications. Is your architecture truly built to survive the failure of an entire data center complex? Now you have the tools to make sure the answer to that question is a confident yes. Thanks for tuning in.